Okay, we're going to jump back into finding area on page 707. We did the perimeter part of looking at a coordinate plane and using ordered pairs to find perimeter. Now we're going to take a look at the area. It says you can find the area in the figure that has been drawn on a grid paper or graphed on a coordinate plane. So if you take a look, it says find the area of the figure in square units. Obviously, we know everything is not going to be a perfect trapezoid. It's not going to be a perfect rhombus. Everything isn't going to be a rectangle. So we want to remember that as we go and we look through some of these problems that are going to have shapes that look like this, okay? It's going to be different. So you have to break it up into two parts. And you're going to see that they drew this dotted line right there so that they could break it up into a rectangle and they could break it up into a trapezoid. Now, are we going to have to do it on every single thing? No, some of them might just be a parallelogram like the picture down below, okay? Some of them might be a rectangle by itself. You won't have to break it up. I mean, there's no point. You just have to break up those shapes that we can actually try to find the area of by taking the two parts out. Or three parts, depending on what it might be. So taking a look at this example, like I said, they broke it down to the area of a rectangle, which the area of a rectangle is length times width. And then they did the area of the trapezoid, which is 1/2 height times base plus base, times base 1 plus base 2. Okay, so after they had solved that problem, they got their units squared. And we're going to actually just do more examples on the other page, but let's start off and take a look at D right here. So let's find the area in square units of the figure to the right. Well, this is a parallelogram, and we all know that the area of a parallelogram is A equals base times height. So let's figure out the base. 1, 2, 3. So my base is 3. And remember, my height has to create that 90-degree angle. Okay, so therefore, this is 1, 2. So my unit is 2. So A equals 3 times 2. And A equals 3 times 2 is 6, so it is 6 units squared. So it's pretty small. It's a pretty small little area. All right, let's take a look at the next page and let's do some examples. Okay, we're going to actually just jump right into this example right down below as we take a look at E together. All right, so when we're looking at E, what we're going to do is we are going to first graph the figure. Okay, and then we are going to classify it, meaning is it a trapezoid, is it a triangle, is it a rhombus, is it a parallelogram? Okay, so we're going to just classify it, and then we are going to find the area. So let's first go ahead and get started on this, and we'll take a look, and let's start with 3, 3. So we're going to graph 3, 3. So over 3, up 3, right there, and then over 3, up 6, and then 5, 6, over 5, up 6, and then over 8 and up 3, and then we get to play connect the dots to figure out what shape this is, and we know that that is a trapezoid. So the first question says graph and classify it, so we're going to write that it is a trapezoid. Okay, and then it wants us to find the area. So we're going to go back to what we know about our formula for area for a trapezoid, and that is A equals 1/2 base, 1/2 height, not base, and then base 1 plus base 2. So now we're going to go back in and fill this in. So 1/2 equals our height. So let's figure out our height. Remember the 90-degree angle. 1, 2, 3. So our height is 3. And then we're going to add our base 1. So this is base 1 at the bottom. 1, 2, 3, 4, 5. I'm going from point to point. So we know that base 1 is 5 plus base 2 is up above, 1, 2, and that's 2 units. So now we're going to do A equals half, and I would just type it in your calculator as 0.5 times 3 times, what is 7, or I'm sorry, oh man, what's 5 plus 2? It is 7, and when you multiply that all together on your calculator, you get an area of 10.5 units squared. All right, let's take a look at some examples. So we're going to do these practice problems together. All right, so while we're practicing these problems together, make sure you're working them out as well. It says use the coordinates to find the length of each side of rectangle, then find the perimeter. So we're going to take a look at the x and y, and so we're just going to line them up. So the first one is 3, 3, then it is 3, 5, then it is 7, 5, and then it is 7, 3. Okay, so let's take a look first at the x's and we'll subtract the y's. So I have these two that are in common, which means I'm going to subtract 5 minus 3, which is 2. I see 7 and 7 are common, which means I'm going to subtract 5 minus 3, which is 2. And then I'm going to now look at my y and subtract my x. So my 5 and my 5 are the same, which means I'm going to take 7 minus 3, which is 4. And then I see 3 and 3 are the same, which means I'm going to take 7 minus 3, which is 4. And when I add those up together, I get a total of 12 units for my perimeter. All right, let's take a look at the next one over here. The next one is 3 and 0, 6 and 0, 6, 7, and 3, 7. So let's take a look at the x's. And I see that 3 and 3 are the same, which means I'm going to subtract my y's. So 7 minus 0 is 7. And then I see 6 and 6 are the same, which means I'm going to subtract my y's, which 7 minus 0 is 7. And now I come back over here. My 0, 0 are the same, so 6 minus 3 is 3. I see 7 and 7 are the same, so 6 minus 3 is 3. When I add those up together, I know 7 and 3 make 10, so 10 and 10 is 20 units. Okay, so let's take a look at the next one, number 3. It says, Mrs. Peel is building a fence around the perimeter of her yard for her dog. The coordinates of the vertices of the yard are 0, 0, 0, 10, 5, 10, and 5, 0. If each grid has a length of 100 feet, that's important because we're going to have to multiply at the end, find the amount of wire in feet needed for the fence. What shape is her yard? Okay, so we're going to first start with the first question, and we're going to do 0, 0. So let's just line these all up and let's get our perimeter. 0, 10, 5, 10, and 5, 0. So let's take a look at the x coordinates that are the same, 0, 0, which means I'm going to take 10 minus 10, or I'm sorry, 10 minus 0, which is 10. Okay, and then I see 5 and 5 are the same, which means I'm going to subtract 10 minus 0, which is 10. And now I'm going to look at my y. So 10 and 10 are the same, which means I'm going to take 5 minus 0, which is 5, and then 0 and 0, which means 5 minus 5 is, I'm sorry, 5 minus 0 is 5. So when I add those all up, I'm going to get, I'm going to kind of move down here, I'm going to get 30 units. But we're not finished because remember that each of them is 100 square feet. So we need to multiply that by 100. So when I take 3 times 1, I get 3, and then I'm going to add my 3 zeros. So it's going to be 3,000 unit, or not feet. I'm sorry, it's actually feet, not units, because it says right there, feet squared. Okay, so that's my area, so 3,000 feet squared. All right, so it wants to know what shape this is. So if I were to do this, I would mentally think, okay, 0, 0 might go right here. So there's 0, 0. What other one has the same x-axis? 0, 10. So 0 up 10, 0, oops, I don't know what just happened, 0, 10. And then I see that I have 5, 10, so maybe over 5 up 10 is going to put me right about there. And that gets me at, what did I say, 5, 10. And then over 0, over 10, when I connect the dots, that makes a nice little rectangle. Okay, so now what we're going to do is we're just going to pop over to the next page and we're just going to take a look at these two problems. And actually, we're just going to take a look at number 5 because we already know how to do the area of a parallelogram, but we need to know how to do a problem like this. So here's what I would do. I can see that I could probably make this into 2 rectangles by cutting a dotted line right here. Okay, so I have now made 2 different shapes. I know that if I'm looking at this rectangle, I know that that means length times width, okay? So that's the formula that we're going to use, is length times width. So we're going to go ahead and go over and figure out the length and then figure out the width. So here's my length, 1, 2, 3, 4. So that's 4. And this one is 1, 2, 3, 4, 5. Okay, so we're just figuring out right now this area of that rectangle. So A equals 5 times 4. A equals 20 units squared. All right, and then let's figure out this next part right here. We'll switch a different color. So we're now trying to figure out this part right here. So A equals length times width. A equals 1, 2, 3, 4. 4, 1, 2. So I'm going to take 4 times 2. A equals 4 times 2 is 8 units squared. So now we're going to combine both of those because that's going to give us the area of the entire shape. So when we add them up, 20 plus 8 gives us 28 units squared. Now let's check it, because this part is actually really cool, because you're like, well, Mrs. Horner, that's awesome. Who cares? Let's see if it actually makes 28 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay? It's crazy how it all works out. So, you are good to go now with your homework. Go ahead and get started. Take your time. Show your work. Show the formulas, okay, just like I've been teaching you, and you are good to go.